Hi everyone, this is Mr. Samer, the physics teacher. We will start with general revision about chapter 5, section 1. Remember that we have studied work net equal F that cause a displacement, force that cause a displacement. So because of that, Fd cosine theta, and the unit of work joule, and it's equivalent to the Newton times meter. Section 2 talking about the energy defined as the ability to do work. So the first kind of energy, it's the kinetic energy. All objects, the objects in motion, have the ability to do work. This kind of energy depends on the object mass and the object speed squared. Kinetic energy equal half mv squared. Kinetic energy called also the energy of motion, and it's also scalar quantity like work and the unit joule, and you can say also joule equal kilogram times meter squared over second squared, and it's also equivalent to the Newton times meter, and we did that before. To connect between the kinetic energy and work, you know that work equal Fd. If F parallel to the displacement, no need to write cosine theta. And F equal ma. And you can use delta x instead of d. A delta x, you can got this value by using the motion equation v final squared equal v initial squared plus 2a delta x. Resolve this equation for a delta x, you will find that a delta x equal v final squared minus v initial squared over 2. Now substitute this value in the place of a delta x, that's mean work net, just rearrange that again, you will find that work net equal half mv final squared minus half mv initial squared. This value called the kinetic energy. So work net equal kinetic energy final minus kinetic energy initial, that's mean work net equal the change on kinetic energy. This formula known as the work kinetic energy theorem. So again, Fd cosine theta equal F net equal work net equal also the change in kinetic energy. This part called work kinetic energy theorem. And we can say that the work kinetic energy theorem says that the net work done by the net force acting on an object is equal to the change in the kinetic energy. Again, the net work done by the net force acting on an object is equal to the change in the kinetic energy. You can rewrite this equation again as work net according to the given quantity actually in each problem. Work net equal half mv final squared minus half mv initial squared, and this is the kinetic energy final minus the kinetic energy initial. So Fd cosine theta equal work net equal the change in kinetic energy, and the kinetic energy unit equal the work unit, and it's equal to, and it's joule. Let us use this formula to solve the sample problem, page 161. In this problem, a frozen pond person kicks 10 kilogram sled, so mass equal 10 kilogram. Giving at an initial speed, V initial, equal 2.2 meter per second. How far does the sled move? How far does the sled move? That means the question asks about D. How far does the sled move until stop? That means V final equal 0. And the coefficient of kinetic friction is 0.1. In this question, there is only one force acting on the object, the friction force. Yeah, some students ask me, Mr., there is a force from the person. No, we are talking about the situation after the person kicks the sled. So there is F net equal F friction, the kinetic friction only, and F kinetic friction equal mu K F normal. F normal equal mg. Now let us use the formula above. F d cosine theta equal the change in kinetic energy, mu K mg, this is F net times d cosine theta equal half mv final squared minus half mv initial squared. Now be careful, v final 0, so half mv final squared, all of it equals 0. Theta, it's the angle between the force and the displacement. Friction force always opposes the motion direction, so theta equal 180, and cosine 180 equal -1. So you can write minus mu K mg equal minus half mv initial squared. There is m in both sides, so you can cancel m with m. I forgot to write d. And you can keep d in one side alone, d equal, and you can cancel the minus sign together also. D equal v initial squared over 2 mu K g. Substitute the values now. 2.2 squared over 2 times 0.1 times 9.8, d equal 2.5 meter. I hope that this sample problem will be clear, and I want you again, I know that some classes did this practice, but I want you again to show me your work and to solve the practice page 162 and see, and I will send you the answer later. Solve this practice page 162 and send me your work in eSchool. Thank you so much.